Hi everyone. So today we'll continue to solve the end of chapter 4 problems. And this is the first problem that we are going to solve for today. This is problem number 4-101. Okay, which is about the nominal interest rate and effective interest rate. So Pete borrows $10,000 to purchase a car. He must repay the loan, I believe is typo. Repay the loan in 48 equal end of period monthly payments. Interest is calculated at 1.25% per month and determine the following. The part A, the nominal annual interest rate. Part B, the effective annual interest rate. And part C, the amount of the monthly payment amount. Okay? Oops. Okay, so first, let's work on the part A. So we are working on problem 4-101 and part A. And we've learned this formula, which is I equals R over M. Hannes, could you focus on this writing area in the camera? Okay, thank you. So here we've learned this formula, I equals R over M. What is I? I is the interest rate per compounding periods. So here I is the interest rate per compounding period. What is R? That is the nominal interest rate, right? And what is M? M is the number of compounding periods per year. So here, for part A, we want to obtain R. So R would be I times M. Right? I is given as 1.25% in the problem description, right? 1.25% per month. What is M? M is the number of compounding periods per year, because there are 12 months per year in a year, so M would be 12, right? So how much is that? It's going to be 15%, right? So the nominal interest rate is 15%. What about part B, the effective annual interest rate? Part B. We also learned the effective interest rate can be obtained by this formula. 1 plus I to the power m minus 1. Here, I sub a is the effective interest rate, right? So 1 plus 1.25% is 0.0125, right? To the power m. M is again 12 because there are 12 months in a year. Minus 1. So how much is that? Okay, this is 0.1608. Okay, so the effective interest rate would be 16.08%. This is the answer for part B. Okay, then what about part C? The amount of the monthly payment. So if you draw the cash flow diagram, this is the problem 4-101, part C. So we have present sum of money, which is $10,000. 0, 1, 2, up to 48 equal and the period monthly payment. So the last one should be 48, right? And 48 equal payment. So we want to find A, right? And what interest rate we're going to use? That is 1.25%. I is 1.25%. Okay? So, how'd you get A? A is 10,000 times A given P, right? A given P, and 1.25% over 48 periods. Let's see if the compound interest table from our text provides this value. So we are looking at 1.25%. So it's on the page number 599 over 48 periods, right? Okay, there is one. Okay, A given P. There is 0.0278. 0.0278. That is the factor value. Okay? Then how much is that? 10,000 times this. So it's going to be $278. Okay? So this is the answer. That is the monthly payment amount. Okay? Okay, then next problem that you are going to solve is problem number 4-103. Okay. So, the journal costs $206, payable now, for a 2-year subscription. The newspaper is published 252 days per year, 5 days, which is 5 days per week, except holidays. And if a 10% nominal annual interest rate, compounded quarterly, is used, then what is the effective annual interest rate? And also we need to compute the equivalent interest rate per 1/252 of a year. And also what is subscribers' cost per copy of the newspaper, taking interest into account. Okay. So let's work on the part A first. So you're working on problem 4-103. Part A. Okay. Okay, so the 10% nominal annual interest rate compounded quarterly, right? So 10% nominal annual interest rate compounded quarterly means that the bank charges 2.5%. The bank charges 2.5% quarterly. How'd you get this 2.5%? 10% divided by 4, because there are 4 quarters in a year, right? So that we're going to have 2.5%. Okay, down here. So the effective interest rate will be calculated by I sub A equals 1 plus I to the power m minus 1, right? So here 1 plus I is 2.5%, 0.025, right, to the power m, because there are 4 quarters in a year. M would be 4 minus 1. So how much is that? Okay, it's going to be 0.1038. So 10.38%. That is the effective interest rate. What about part B? Compute the equivalent interest rate per 1/252 252 of a year. Because the effective interest rate is 10.38% from Part A, we may look backwards to compute the equivalent I value for 1 over 252 of a year. Okay, so here we are working on Part B. We know that effective interest rate is 10.38% from Part A. So here 1 plus I to the power 252 days minus 1 would be 0.1038, right? So 1 plus I to the power 252 would be 0.1038 plus 1, right? So this is exactly same as this, right? 1.1038 to the power negative 252. Is that correct? So how much is this? This is the 1.000392. Okay? So I would be this minus 1, which is 0.000392, which is 0.0392%. Okay? This is the equivalent interest rate. Equivalent interest rate per 1 over 252 of a year. Okay? Okay, then how about Part C? What is a subscriber's cost per copy of the newspaper, taking interest into account? So we are working on Part C. Okay, so for a for a 2-year subscription, you pay how much? $206, right? Up here, for a 2-year subscription, you pay $206. So let's draw the cash flow diagram for this first. So here we have P present sum, which is 206. 1, 2, 3, and so on. Up until how many periods? The newspaper is published 252 days per year. So the interest period would be 504, right? Because 2 times 252 becomes 504. 2 times 252, right? And we want to know uniform series amount, which is A, right? And we already calculated the interest rate from part B, which is 0.0392%, right? I is 0.0392%, okay? From part B, okay? So how'd you get A? A equals P times A given P I over N. So it's going to be 206 times A given P I is 0.0392%, and over 504 periods. And the compound interest table from our text does not provide this value. So you may want to go with the formula, which is 0.0392 times 1 plus 0.0392 to the power n, which is 504, divided by 1 plus 0.0392 to the power n, 504, minus 1. Okay, what is this? Okay, this is the about 45 cents, okay, which is the 45 cents per copy. So this is the subscriber's cost per copy, that is 45 cents. Okay. And to check, if you ignore the interest, the cost per copy would be how much? $206 divided by 2 times 252. right? How much is that? That is 40.8 cents. So ignoring the interest, the cost per copy is 40 cents, a little bit over 40 cents per copy. So the answer of 45 cents per copy looks reasonable. Okay? So just for the double checking purpose, okay, you can do this simple calculation and compare it with the real value, okay, whether this value is reasonable or not. Okay, so next problem that we are going to solve is, let's go back to chapter 3, problems, which is 3-46. You know, our textbook provides the nominal interest rate and effective interest rate in both chapters 3 and 4. So both chapters, end of chapters 3 and 4 provides the problem sets for nominal interest rate and effective interest rate. So this time, let's go back to chapter 3, end of chapter 3 problems, which is 3-46. A bank is offering to sell 6-month certificates of deposit for $9,500. At the end of 6 months, the bank will pay $10,000 to the certificate owner. Based on a 6 month interest period, compute the nominal annual interest rate and the effective annual interest rate. Okay, so you are working on problem number 3-46. This is about nominal interest rate and effective interest rate. So again, I want you to recall your memory about this formula. I equals R over M. Okay. Here, R is the nominal interest rate, right? And I is the interest rate per compounding period. And M is the number of compounding periods per year, right? So here, P is given as $9,500. And the future sum of money, which is $10,000. Right? And we want to know the I value, right? And what is N here? N is equal to 1. 6 months interest period, right? So here F is equal to P times 1 plus I to the power N, which is 1. So using the real value, 10,000 equals 9,500 times 1 plus I. Right? So 1 plus I is equal to what? That is going to be 10,000 divided by 9,500. So how much is that? It's going to be 1.0526. So I is 0.0526. So I is 5.26%. Okay. Now go back to this formula, because we know that I is 5.26%. And we want to find out the R value. What is the value of M? M is 2, because there are 2 6-month periods in a year. Okay? So R equals I times M. I is 5.26%, which is 0.0526, times M equals 2. So that's going to be 5.26% times 2, 10.52%. Okay. So this is the nominal annual interest rate. Then how would you get the effective interest rate? Effective interest rate, which is represented by I sub A, is equal to 1 plus I to the power M minus 1. Right? I is 0.0526, 0.0526 to the power M equals 2 minus 1. So how much is that? Okay, so this value is 10.797%. So this is the effective interest rate. Okay. Okay, now let's go back to chapter 4, end of chapter problem. Which is problem number 4-104. So you are taking a $2,000 loan. You will pay it back in 4 equal payments, paid every 6 months starting 3 years from now. And the interest rate is 6% compounded semi-annually. And you are required to calculate the effective interest rate based on both semi-annual and continuous compounding, and the amount of each semi-annual payment and the total interest paid. Okay, so let's work on the part A first. So we are working on problem number 4-104. Again, we are going to use effective interest rate. I sub A equals 1 plus R over M to the power M minus 1, or using the relationship I equals R over M. This becomes 1 plus I to the power M minus 1, right? You know, I is the interest rate per compounding period. R is the nominal interest rate. M is the number of compounding periods per year, right? So I want you to keep in mind this. So here we have 1 plus R. R is how much? Is 6%, right? So it's 0.06 divided by M. What is M? In this case, it's going to be 2, because there are 2 semi-annual periods in a year. And and to the power M again, which is 2 minus 1. So how much is this? Okay, this value is 0.0609. So 6.09%. Okay, so this is the effective interest rate based on semi-annual compounding. Semi-annual compounding. Okay. Now let's compute the effective interest rate for the continuous compounding. So the effective interest rate based on continuous compounding. How would you get this? There is a formula I sub A, effective interest rate for the continuous compounding can be obtained by e to the power r minus 1. Okay. Again, the r is 0.06, 6%. 0.06 minus 1. So, what is this value? Okay, and this value is 0.0618, okay, which is 6.18%. So this is the effective interest rate based on the continuous compounding. Of course, this value is larger than the one for the effective interest rate based on semi-annual compounding, right? Okay, now let's move on to part B. We are required to compute the amount of each semi-annual payment. So let's draw the cash flow diagram. So you are taking a $2,000 loan. So P is $2,000 at the end of period 0. Then 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. And you will pay back in 4 equal amounts paid every 6 months. So, so after the second 6 month period, this becomes the first year, right? And second year, third year, right? Because it said that paid every 6 months starting 3 years from now on. So starting 3 years from now on would be right here. You will pay it back in 4 equal amounts paid every 6 months starting 3 years from now on. So we want to know this annual payment, right, for equal payment. So again, because here we are using the unit of semi-annual period. So you are taking $2,000 loan and you will pay back in 4 equal payments paid every 6 months, right? Starting 3 years from now. So your payment will start at the sixth semi-annual period from now on, right? And the interest rate is 6% compounded semi-annually. Compounded semi-annually. So the bank will charge 3% semi-annually. How do you get this 3%? 6% divided by 2, because there are 2 semi-annual periods in a year, right? So 6% divided by 2 becomes 3%. So you are going to use I equals 3%. And we are required to compute the amount of each semi-annual payment, right? So if I said equivalent present sum of, let's use different color. Let's say P prime at the end of period 5. Then how to get this P prime? The P prime equals $2,000 F given P, right? F given P, 3% over how many periods? 5 periods. So how much is this? We are looking at 3% interest rate. So in page number 604 of our text, F given P over 5 periods is 1.159. 1.159. So this is $2,318, right? So we need to convert this P prime to equivalent uniform series over 5 periods. No, over 4 periods, right? From 5 to 9. So uniform payment would be $2,318 times A given P, right? 3% interest rate over 4 periods. So how much is this? 3% A given P over 4 periods, which is 0.2690. 0.2690. So how much is this? Okay, this is the $623.54 every 6 months. Okay, So what he did here is we obtained the future value of the loan, one period, which is 6 months before the first repayment, right? Before the first repayment. And then this value, P prime, has been converted to equivalent uniform payments, okay? So, which is $623.54 every 6 months. Okay, how about part C? Total interest paid amount. The total interest paid amount is the difference between the loan amount and the total amount you paid back, right? So the total interest paid is the difference between the loan amount difference between the loan amount and the total amount you paid back. So how would you get this value? How much was the 4 equal payment? From part B, you got $623.54 for every 6 months, right? So you need to multiply by 4. $623.54. Then this is the total amount you paid back, right? And how much is the loan amount? From the problem description, it is given as $2,000, right? So minus 2,000. Then how much is this? Okay, so this is the $494.16. So this is the total interest you paid. Okay. Okay. Now let's solve problem 4-107. Okay. A local lending institution advertises the 5150 Club. A person may borrow $2,000 and repay $51 for the next 50 months, beginning 30 days after receiving the money. Now you are required to compute the nominal interest rate for this loan. Also, you need to compute the effective interest rate as well. So we are working on problem 4-107. Okay, and let's draw a cash flow diagram first. So you borrow $2,000 right now. Okay, so you have $2,000, and we pay $51 for the next 50 months, right? Beginning 30 days is 1 month. Beginning 1 month after receiving the money. So you have uniform series of $51, right? 0, 1, 2 up to 50th month, right? And we want to know the interest rate, okay? So how would you get this interest rate? Here, 51 equals 2,000. A given P, and I percent over 50 periods, right? So A given P, I percent over 50 periods is equal to what? 51 divided by 2,000. How much is that? That is 0.0255. Okay? So hopefully we can find the corresponding interest rate for that. So for example, if you want to look at 10% interest rate, if 10%, then this vector value is 0.1009, 0.1009, which is too much, right? A lot larger than this value. So let's look at 3%, for example. A given P for 50 periods is 0.0389. 0.0389 if 3%. So it's still larger than this value. So let's look at 1%, A given P over 50. Oh, okay. So if it's 1%, we have 0.0255. 0.55, which is exactly same as this value. Okay? So, I do say the I is 1% per month. Is that right? So, now we use the formula. I is R over M. Here we've got I equals 1%. So what is the value of M? Because there are 12 months in a year, M is 12, right? So R equals I times M. I is 0.01, M is 12. Okay. So what is this? 0.12, which is 12% per year. So this is the nominal interest rate. Okay. We are also required to get the effective interest rate. Since you already got the nominal interest rate, the effective interest rate can be obtained by 1 plus R to the power M minus 1, right? So 1 plus 0.0, this is going to be I, right? So 1 plus I to the power M minus 1. Sorry. So it's going to be 1 plus I is 1%, right? Earlier. So 0.01 to the power M. M is 12 because there are 12 months in a year, minus 1.